So last video, we talked about how to find intercepts if you had a linear equation. This time, let's do the same thing by using a quadratic equation. So again, the difference between this quantitative reasoning class and a algebra class is you have to know context. So let's take a moment and talk about context. Let's talk about what each of the letters mean. So Farmer Bob has 60 feet of fencing to make a rectangular pen for some pigs. If he makes the pen W feet wide, the area of the pen will be A of W equals a negative W squared plus 60W. Find the intercepts and explain their meanings in the context of this problem. So again, we've got two letters kind of in our equation. The first letter is a W, and that represents W feet wide, so that's the width of the pen. And so if he makes the pen W feet wide, the area of the pen will be A of W, so this A of W represents area of the pen. And we normally think of things in terms of X and Y, but there are no X and Y's here. So let's kind of remind ourselves which one's X, which one's Y. So because the W is inside the parentheses, that's what we think of our X value, our input value. And then remember that this A of W is just a fancy way of saying Y. So here's our Y value. Okay, let's find intercepts. To find intercepts, let's find y-intercept first. Yeah. To find the y-intercept first, we set x equals to 0. But again, we don't have an x here, so we have to go to our x value is our w value. So we're going to set the w equal to 0. So here's our equation, a of w equals a negative w squared plus 60w. So since we're setting the w's equal to 0, anywhere that you see a w, you're going to plug in a 0. So in this case, our a of 0 is going to be a negative 0 squared plus 60, 0. When I simplify that down, I get 0. Well, let's put this into the context of the problem. So when my W is 0, that means when the width is 0, then what's my A of W represent? A of W represents area. The area is 0. And that makes sense. That makes total sense. That if I don't, as I'm starting out, I don't have any width. And so my area of the pen is going to be 0. Okay, so then let's talk about x-intercept. This is the little bit more. Now let's find the x-intercept. So to find the x-intercept, we say you set y equal to 0, but in our problem, we don't have a y. And so we have to go back and say, well, our y value we said was a of w, and so we really want to set this a of w equal to 0. So again, here is my equation. And I want to take this entire a of w and replace it with 0. So now I've got 0 equals a negative w squared plus 60w. Okay, so when I go to solve this equation, because of this squared term here, this little square right there, I cannot solve this like I did in the linear equation. There is a whole nother process. You can use factoring. And so if you know how to factor this, then you can definitely go and factor this. But the way that we've done it in class is we use the quadratic formula. And so this is the point where you use the quadratic formula to find the x-intercept of a quadratic equation. So remember, here is my quadratic formula. And so the next thing we have to do is we have to determine what is the A, what is the B, and what is the C. So remember, the A is the number in front of the x squared, not including the x squared. And B is the number in front of the x, not including x. And C is the number by itself. So in this problem, again, we don't have x's, we have w's. And so A is the number in front of my w squared. So this number, what number is in front of the w squared? Well, I see this negative here, and so that represents a -1. So in my case, A is a -1. My B is the number in front of x, but I don't have an x, I have a w, so it's the number in front of the w, which would be 60. And my C is the number by itself. Well, I don't have a number by itself here. And so what is my C value? Well, I can always add 0. And so in this case, my C value is 0 because I don't have that number by itself. So if we plug those three values into, we're not doing x's, we're doing w's, into my quadratic formula, I get a -60 plus or minus square root of 60 squared minus 4 times -1 times 0, all over 2 times a -1. So okay, if you have a multi-step calculator, you can do what's called the discriminant. You can do this part in your calculator as one big step. When you do that, you should get 3,600. I'm going to go ahead and multiply that out. Let's go ahead and do this part next. So we take the square root of 3,600, and in our case, that's going to be 60 again. And now at this point, we've got two different problems. We've got a -60 plus 60 divided by -2, and we've got a -60 minus 60 divided by a -2. Let's go ahead and simplify both of those out. So a -60 plus 60 is 0 divided by -2, or just 0. And a -60 minus 60 is a -120 divided by -2, which is 60. So we have two answers. We've got w equals 0 and w equals 60. Okay, now comes the big quantitative reasoning question. What do those mean? We've got those two answers together. So what do they mean? So remember, we did this all the way back up here. We set A of w equal to 0. So when A of w equals 0, w equals 60 or 0. So let's put that in the context of our problem. When the area is 0, the width is 60 feet or 0 feet. Does this make sense? So if we've got 120 feet of rope, if we put no amount of rope into the width, so it's all into the length, then we've got basically two lines of rope just kind of laying against each other. There's not going to be any area. The other opportunity is when we put 60 feet into width, that means we need 60 feet of width back. That means our length has nothing. And so we also have no area then. So we have two opportunities for the area to be 0, is either if you put all your rope into width or if you put none of your rope into width, then we're going to have a pen that has no area. I hope that helps.